This is the color scheme that I use for my videos. Make sure you copy down the black.
This is a really tricky problem because there's a lot here to manage. What you realize is that you have to find the slope. And so it's kilometers and degrees. And so you can set this up as x1, y1, x2, y2. y2 minus y1 over x2 minus x1 will give you the slope. And the way that I knew to do that is for every additional 10 kilometers of Earth's surface, the temperature in the mesosphere decreases by K Celsius. So we're expecting this to be a negative answer, and then K is a constant. So it's basically Celsius degrees per. We're looking for a slope that's degrees per kilometer. So the degrees have got to go on the top, and the kilometers have got to go on the bottom. You might think that the answer is negative 25. Be careful because it decreases by, you want to know by how much it decreases. The slope is going to be negative 25 over 10. Like the slope here is, this is really the slope, negative 5 over 2. And it's a negative number, and so that means it's going down 5 halves of a degree every kilometer. So what we want to do is we want to ask the question, by how much is it going down? It's going down by 5 halves, and multiplying by that by 10 for every 10 kilometers, you get 25. So the easiest way I think to get that is to find the slope and set that equal to negative k over 10, because this is how much we're decreasing for every 10 kilometers. Setting up this proportion, you can see that k has got to equal 25. A slightly faster way to get there is just to get to this part and realize that we need to get a 10 on the bottom. That's for every additional 10 kilometers. So you can divide this by negative 3 and get 25. Either way, k is 25. It's decreasing by 25 degrees every 10 kilometers. Here's a trapped number. You don't need to use this at all, and then you really don't need to use this number at all either. They're just additional numbers written in the problem that you don't have to actually calculate with.